A crimson error message blocks your JavaScript fetch request because the browser detected a mismatch between origins. This security barrier is known as the same origin policy, and it is designed to keep your sensitive user data safe from malicious scripts on third-party sites. An origin consists of three specific parts, which are the protocol, the hostname, and the port number. If any one of these elements differs between the requesting page and the destination server, the browser triggers a mandatory security check before allowing data transfer. The browser protects users by default through the same origin policy, which restricts how a document or script loaded from one origin can interact with a resource from another origin to prevent cross-site request forgery and unauthorized data extraction from private sessions. Cross-origin resource sharing is a mechanism that uses additional hypertext transfer protocol headers to tell browsers to give a web application running at one origin access to selected resources from a different origin, and it defines how these two entities interact safely. For security reasons, browsers restrict cross-origin requests initiated from scripts unless the response from the other origin includes the correct headers. This rule applies to all modern application programming interfaces, whether they use JavaScript object notation or extensible markup language for data exchange. When a script attempts a request that could affect user data, like a post or delete, the browser first sends an options request, known as a preflight. This asks the server for permission and confirms which methods and headers are actually allowed for the operation. The preflight request uses the options method to communicate the intended origin and the intended headers of the actual request. The server must be configured to handle this specific method and return a successful status code to proceed with the primary data exchange. A server must respond to a preflight request with specific headers that explicitly authorize the origin, method, and headers mentioned in the request. Without these matching values, the browser will immediately terminate the connection and throw an error in the developer tools console. The most important header is access control allow origin, which specifies which domains are permitted to access the resource. If this header is missing or contains a value that does not match the request origin, the browser blocks the final data transfer entirely. In a Node.JavaScript environment using the Express framework, you can handle these headers manually by writing a middleware function. This function uses the response.setHeader method to apply the necessary security strings to every incoming request before they reach routes.
Order matters when defining middleware in Express. You must place your cross-origin resource sharing logic above your route definitions to ensure that the browser receives the correct headers even if the request is eventually handled by a specific application programming interface endpoint. Manually managing these headers for every possible scenario is tedious, so most developers use the official cross-origin resource sharing middleware package. This library handles the complex logic of matching origins and responding to preflight options requests automatically with minimal configuration code. After installing the package, you can apply it globally to your Express application using the app.use method. By calling the function without any arguments, you enable a basic configuration that allows all origins to access your resources using a wildcard symbol. While a wildcard allows all origins to access your resources, it is often too permissive for production environments. This setting should be avoided for sensitive data because it bypasses the browser's safety checks that prevent malicious websites from making requests on behalf of users. You can pass a configuration object to the middleware to define an origin property that contains a single allowed string or an array of trusted domains. This whitelist approach ensures that only your authorized front-end applications can communicate with your backend server.
When your application needs to send cookies or authentication headers, the server must include the access control allow credentials header set to true. This tells the browser that the response can be shared with the script, even when it contains sensitive identification data. A critical rule is that the access control allow origin header cannot be a wildcard if the allow credentials header is set to true. The browser will reject this combination because it creates a major security vulnerability where any site could read private cookies. Browsers also check for allowed methods during a preflight. If your React application tries to use a patch request, but the server only authorizes get and post through its headers, the browser will reject the operation, even if the server code actually supports it. You must include the access control allow methods header to specify which operations like get, post, put, or delete are permitted. In the middleware configuration, you can define this as a comma-separated string or an array to inform the browser of supported actions. Custom headers like authorization or content type must be explicitly permitted using the access control allow headers response header during the preflight check. If the browser sees a header in the request that was not approved by the server, it will block the call.
If you want your client-side JavaScript to read custom headers sent back from the server, you must use the access control expose headers header. By default, the browser only allows access to a few standard response headers while hiding any custom application data. Sending a preflight request for every operation adds significant latency to your application. You can optimize performance by using the access control max age header to cache the preflight result for a specific number of seconds, so the browser skips the check next time. In React development environments, the frontend usually runs on port 3000, while the Node.JavaScript backend runs on port 5000. This creates a cross-origin conflict on your local machine because the ports are different, even if the host is localhost. To bypass this during local development, you can add a proxy field to your package.javascript file in the React project. This tells the development server to forward any unknown requests to your backend server address while appearing to stay on the same origin. Using a proxy makes the browser think the requests are going to the same origin as the front-end application. This avoids the need for complex cross-origin headers during the initial coding phase and simplifies the development of your internal application programming interface calls.
When you move to production, the proxy in the package file no longer works because the React development server is not used to serve the final build. You must ensure your production server or load balancer is configured to handle the origins correctly for the live environment. A common professional solution is to use a reverse proxy, like Nginx, which can serve both the static React files and the Node.JavaScript application from the exact same origin. This removes the need for any cross-origin configuration at the application level. If a reverse proxy is not an option, you should use environment variables to inject the correct allowed origins into your server configuration. This allows you to support localhost during development, while strictly enforcing your production domain once the application is deployed to the cloud. Debugging these issues effectively requires opening the browser developer tools and looking at the network tab. You must inspect the exact headers of both the preflight options request and the actual data request to find the discrepancy that is causing the browser to block access. Check the request header section to see what the browser is asking for and compare it carefully to the response header section to see what the server is actually granting. Most errors are caused by a missing header name or a small typo in the domain string.
Sometimes the error occurs because the server crashed or returned a 500 error before it could set the proper headers. The browser then interprets this lack of headers as a cross-origin violation rather than a server failure, which can be misleading during initial troubleshooting. Ensure that your error-handling middleware in Express also sets the necessary cross-origin headers. This allows the client-side application to actually read the error details and status codes from the server, instead of being blocked by the browser security layer during a failure. Security is always a balance between protection and functionality. While it is tempting to use a wildcard to solve all errors quickly, it exposes your users to cross-site request forgery. Always strive to be as specific as possible with your allowed origins and methods. Always verify the origin against a list of trusted domains on the server. If the request origin is found in your authorized list, you should echo that specific origin back in the response header, instead of using a generic wildcard, to maintain high security standards. Simple requests like those using the application xwww form URL encoded content type may skip the preflight options check entirely. However, they still require the correct origin header in the final response for the browser to allow the script to read the data returned by the server. Complex requests using JavaScript object notation or custom headers always trigger a preflight. This is where most developers encounter the persistent errors that halt application development because the server is not expecting the options request that precedes the actual put or post operation. Remember that the browser ignores these resource sharing rules if you are making requests from a mobile application or a server-to-server environment.
These rules are strictly a browser security feature designed to protect web users from malicious cross-site interactions within their browsing session. This mechanism exists because your browser automatically includes session information, like cookies, in requests. Cross-origin resource sharing ensures that a random website cannot use your active session to perform actions on your behalf at a different domain without the server's explicit permission. By correctly implementing the headers and understanding the preflight lifecycle, you can create secure and robust full-stack applications. The combination of server-side middleware and front-end proxying provides a comprehensive solution for handling any cross-origin communication hurdles you may face. Your final checklist includes verifying the origin host and port, setting the allowed methods and headers, and ensuring that credentials are handled with specific origins. Mastering these networking fundamentals allows you to diagnose and resolve communication hurdles between any modern front-end and back-end architecture.